welcome everyone to the Australian Bitcoin podcast. I'm Justin, your host, and today I'm joined by Lloyd to discuss Lightning Network privacy and his current Bitcoin projects, including Gun, GunFun, and the Frost multi-signature protocol. But before we start, a quick word from our sponsor. The Australian Bitcoin podcast is brought to you by hardblock.com.au. Hardblock is Australia's oldest Bitcoin-only exchange. They have no added fees and are optimized for dollar cost averaging. Sign up to Hardblock today using the discount link in the description below to receive free auto-send batched Bitcoin withdrawals for 6 months. All right, Lloyd, how's it going?
G'day, pretty well.
It's good to hear.
I've just moved to Malaysia. That's one interesting thing. You're still in Australia, so I'm interested to know how you're going. Do you have electricity still? I guess you do. Are you running on batteries at the moment?
No, we've got some electricity still. Apparently, there's just like a little bit left for everyone. We have to ration it or something like that. And things have seemed to become a little bit less draconian in regards to masks and to lockdowns and check-ins and all that sort of stuff. But you know, you never can tell when that's all going to change rapidly again.
Yeah.
Was that maybe some of what prompted the not just trip, but maybe even move to Malaysia to get a bit more freedom?
Actually, no. I mean, there isn't really more freedom. It's more like, if I'm just going to have my rights flagrantly violated, might do it somewhere else that's cheaper,
That's right. Yeah, I suppose that's true. At least you get a bit more flexibility, I think, in that regard.
I also like it here. I just love it here as well.
Have you traveled there much before?
Yeah. My wife's from here, so I've been here for quite a few times, and I really enjoy it. Yeah.
Oh, that's good, and I'm sure she'll appreciate that as well. I actually heard something on the radio this morning that said last year Adelaide, from South Australia, obviously, was rated the third most livable country in the world, or place in the world, sorry. Whereas now, as of this year, we've dropped to rank number 31 or 32 or something along those lines. Australia no longer even features in the top 10, as I understand it. Whereas we used to have a couple of cities in the top 10. And most of that is due to, kind of the draconian overstep of government during COVID and other things that were going on at that time. So, there's obviously an impact. People see it as well.
Yeah.
Look, we might as well pivot a bit and talk about Bitcoin and Lightning Network privacy and everything else. I figure maybe a good chronological way to go into it would be to tell just a bit about your Bitcoin history, like what got you into Bitcoin in the first place, and some of the stuff that you're working on at the moment.
Yeah, sure. I was, like many of your listeners, a shitcoiner in the beginning, somewhere in 2017, 2018. And long story short, I guess like many people, the bear market makes people into Bitcoin maximalists. And by the end of 2019, I was firmly a Bitcoiner, let's say. And from there, but my stint in shitcoinery got me interested in cryptography, actually. So I do owe some debt of gratitude to them, because I was trying to figure out which shitcoin was the better one based on its scientific achievements, let's say. And so I learned some of the basics of there, and I transferred that over to Bitcoin when I saw how many interesting things were going on in the cryptography space in Bitcoin, and got interested in that field, started making some contributions to the theory around Bitcoin cryptography, I guess, some minor ones, and continued to do that. Became involved in engineering as well as a software engineer. Was naturally got involved in that and building the systems and building the cryptography that I thought would be helpful to Bitcoin's future. And so I sort of look at Bitcoin protocols from a sort of try and be from a theoretical perspective, and try to really get to the bottom of not what the practical reality of the protocols are today, but how they are right now, but how they could be and how they might change in the future as we develop the science of this Bitcoin related cryptography better.
It's true, I guess, when something is relatively new and there's going to be many new discoveries that spring from it, it's hard to envisage the next system or what it's going to look like in future, isn't it? But I mean, that's part of the job. We have to try to have at least the general direction or a rough idea of where it might go to. But as new discoveries spring up, it's going to drastically change the shape of things in future.
Yeah. I made a website called bitcoinproblems.org to sort of just list theoretical problems we have going forward. And there's not a complete list. It's just like whenever I need to brain dump something, I put it on that website, and other people are contributing to it too. So we've got that's sort of one way I try to keep track of these things.
I'll link to that in the show notes, because I hadn't seen that before until you messaged me when we were talking about the podcast. And I've found that really, really useful just to get my head around a few problems which I knew existed, but didn't have kind of a one-stop shop of technical explanations or even proposed solutions. And there was a few things in there that I had no idea about, which was just good to get my head around.
Mm-hmm.
I'm curious, is this something that you have done in the past? As in, do you have past relevant either work or qualifications that kind of led you to this? Or was it really since sort of like 2017, shitcoining, getting into cryptography, and then sort of dabbling a bit more with Bitcoin? Is that the trajectory? Or did you come
not
almost...
at all. Yes, I've become what I am totally in the Bitcoin space.
That's incredibly impressive, man. That's like a very short amount of time to get to the point that you're at now.
Yeah, thank you. It has been a wild ride, yeah.
I imagine one of the things that's probably helped get your head around it would be the wallet that you've developed, which is Gun or Go Up Number, because that's like a command line interface wallet, and you've got like a betting, I guess you just call it betting or wagering. Kind of what would you call it? Like an extension to it called Gun Fun.
Yeah, Gun.fun is really just that's the documentation for the command line wallet.
Gotcha.
That's just the website. The .fun is just because I like things to be fun, and it rhymes with gun. I sort of, going back to COVID, I sort of came up with the Go Up Number backronym while we were in lockdown. So it's more demented. I think it's a more demented name than I would have liked. Actually, I would like to change it. So if you're offended by guns and stuff, I feel you actually on that. It's a command line wallet, but I just sort of wanted to build a command line wallet so we could experiment with Bitcoin protocols without having to go through the whole user experience side of things. So just like a command line where we can just try them out. One protocol I did to sort of start off that direction was a betting protocol that I had on my mind for a while, where you could just post messages between each other on a chat app or on Twitter even, and set up a bet on something with Bitcoin. So with an oracle who would decide the outcome of the event. But to you and I be able to set up a bet sort of semi-privately, even in a public space like on Twitter, between each other. And I implemented that. I did a few bets with people. It didn't really catch on, I think, because of the limited nature of the command line, the limited audience that offers. But it taught me a few things, and about the software engineering of the project, and on about user experience of command line things and how it's not really insufficient. So that's and about how we can develop that kind of protocol in the future as well.
Absolutely. Do you use DLCs for the betting portion of it, or is it something else?
It's roughly a DLC, a stripped down version, so that the amount of communication you can need to do can fit inside a single tweet.
Gotcha. That's really cool. And even just as a way to demonstrate like a concept to people, because I think there's still a lot of people that are into the Bitcoin space that have no idea that we do have these, I hate to say the phrase, but like smart contracts type capability on Bitcoin. And it's certainly growing. And there's already a lot of pretty useful stuff that we can do with it. So even just as a proof of concept, if people didn't like use it a whole lot, that's fair enough. But it's nice for them to be able to see what is actually possible.
Yeah, absolutely. That's sort of the way I'm doing it. What I need to figure out is how to actually, it's a good way of rhetorically explaining to people that we can pretty much do on Bitcoin whatever we want. And it's actually more efficient than on any other kind of platform. That kind of thing would be very difficult on Ethereum or other things to do it in such a way in 2 tweets. And you would leave a bigger blockchain fingerprint, and it would be less private as well. So it's like actually Bitcoin is pretty close to optimal for most protocols. It's just the engineering that you require to reach that optimum is harder, much more limited scope for the people to do it. And those people do not intersect with people who can make good user interfaces. So it's actually like a human problem, the technical problem, a human mapping the humans to the technical problem. The system itself is capable of doing absolutely everything that you could actually reasonably want to do, in my opinion. I mean, there are some exceptions, like we could not do algorithmic stable coins, but I think that that's probably a good thing because they suck. Like all the things you can't do suck. So yeah,
I think that's probably a good filter as well, actually. And you're right. So people either need to upskill themselves in command line interface, or I guess we need more good kind of UX, UI designers to step into the space and make some of the technical stuff more accessible to people that want to.
It's definitely the latter thing. We don't need to upskill people using command line interfaces. It's a bit much to ask. I think it's yeah.
True. Is there a reason that you developed your wallet to do this and couldn't use something like, I guess, the CLI of Bitcoin Core? Like, I'm not really totally sure how they would differ. I guess Bitcoin Core isn't a wallet node, but it's got a wallet built into it. But yeah, could you have done that, or as having your own?
Yeah, you could. And some people sort of do that with their protocols. I'm not a fan of it. I don't want you to have to run Bitcoin Core to do this. So that's, I mean, one thing it uses the mempool.space API to like track your wallet, which is not good for privacy. But it just means working right away, you know.
Very true.
And you can also run your own Explorer instance, which is something that some people do and have it fully self-sovereign. Or in the future, hopefully Electrum. I'll be able to get Electrum working and working on similar things right now.
That's cool. Just gives people a few more options and doesn't restrict them to using, that sort of standard Bitcoin Core implementation.
Yeah. I'm thinking of getting rid of the betting thing. So I pretty much exhausted the usefulness of that protocol in terms of what I can learn from it. So I'm thinking of removing the betting thing from it and more focusing on a more like just a fully featured command line wallet to do basic Bitcoin things, like especially integrating the future developments or the things we're able to do now with Schnorr and Taproot into creating the ideal Schnorr Taproot wallet, but on the command line.
That sounds pretty cool. Is that would that be linking into Frost? Because I'm guessing that uses Schnorr and Taproot.
Exactly. Yeah. So Frost is a new way of doing multi-signatures, which uses Schnorr signatures, threshold Schnorr signatures. It's a threshold Schnorr signature protocol, which means you can do those 2 of 3s or 3 of 5s with a single public key. So you do not put the public keys involved in the 3 of 5s on the blockchain. It looks to everyone else, it looks like a normal single public key. And that's extremely advantageous for many, many reasons, both for yourself and your own privacy, but also for the blockchain, itself, because we'd have much fewer bespoke scripts being revealed and much more effective privacy. The effectiveness of privacy techniques sort of going forward will sort of depend on the proportion of people that adopt Schnorr. And so if people are still using multi-sig with scripts all the time, it sort of weakens everyone's privacy, not just your own privacy.
Yeah, that makes sense because you're kind of hiding in a non-set. So I guess if you have all transactions, hypothetically, if all transactions look the same on the Bitcoin network, that would be great for privacy, because if we had multi-signature setups or even coin swaps or coin joins or something like that all looked exactly the same, it would be impossible to know when someone's doing a privacy conscious transaction versus not.
Exactly. I mean, we're going to probably talk about coin joins a little bit later, hopefully, about when we talk about Lightning privacy and stuff. But the one thing that really sucks about coin joins is that if you're using a 3 of 5 multi-sig, and you're the only one who does, you spend that into a coin join and then you get it out in another 3 of 5 multi-sig because that's your security setup. Well, it's very, very obvious to link your incoming and outgoing coins that way. So yeah.
That's true. And we'll definitely talk about the Lightning side of things as well. But something that I think a lot of people misunderstand with Lightning is that there is an on-chain footprint for that too. Like whenever you open up a channel, it's a 2 of 2 multi-sig transaction. So you can kind of have a look over the network and see how many 2 of 2 multi-sig transactions are in existence. And that would probably be a pretty good ballpark figure of the amount of Lightning channels that are open at the moment. And of course, if some of them are publicized or like made public because they're announced, then you can kind of do a process of elimination and find out how many are private, how many are, would you want to maybe look into to get more detail about. So it does give away a lot having a footprint like that or a fingerprint like that on chain.
Exactly. And so Lightning will be getting rid of this fingerprint Some of that, the fingerprint that you just described, you'll be getting rid of it. And so it'd be great if we could get rid of it for wallets as well. And so we're working on, I'm working on Frost with a few other people to try and get that in, demo it in Gun, but try and get into as many other wallets as possible, I guess.
Yeah, true. I think another thing here that's probably in parallel is the data used on chain, which means something like Schnorr signatures are going to have just like less of a data load on chain, which is better for, I would say, decentralization, because it means nodes are less data heavy. You can fit more into blocks. People are going to be paying a little bit less for their transaction fees. So there's sort of like a convenience or a fee benefit, as well as just an overall not kind of congesting the chain when we don't need to.
Yeah, the beauty of it, we still have an incentive for better privacy. The incentives are aligned for cheaper transactions and privacy as well. So that's a really strong feature of Bitcoin, you can say.
Yeah, very true. For anyone who's listening who can't kind of visualize this or isn't really sure what we're talking about exactly with, say, Schnorr signatures versus how a signature might normally look on chain, I'll try to describe it, and then let me know if I've done that right or wrong, Lloyd. Yep. So at the moment, say if you have a multi-signature transaction on chain, quite a lot of detail about the fact that it's multi-signature, the type of options that you could have, as in whether it's a 2 of 2 multi-sig or a 2 of 3 or a 3 of 5, all of that detail is somewhat presentable on chain, which means an onlooker could really see that and at least know what kind of multi-signature type contract or type transaction that you're performing. Now, it's not just about multi-signature. There's other types of transactions we can do as well where we leak that information, but let's just sort of focus on multi-sig for now. With, say, Schnorr signatures as an alternative, it would look like any other transaction. It would be unclear how many signers are required to, say, sign that transaction. It would be unclear if there's any other kind of options embedded within that contract or that script. And so all of a sudden, you've gained a bit of privacy because someone onlooking doesn't know the kind of transaction that you're performing, doesn't know the other options that would be there. What I mean by other options, as an example, would be, say you might have a 2 of 3 multi-sig, but then you might have something else that says if certain amount of time goes past, then we can actually have, say, like a 1 of 3 multi-sig type transaction. And if you're signing that transaction, kind of all that detail needs to be put in there. Whereas with the Schnorr signature, none of that detail really needs to be put into there. It's just a signal signature. I'm not sure if that makes sense the way I've described that.
But the way when you bring up a really interesting point, which actually demonstrates the power of not just Schnorr signatures, but of Taproot. So Schnorr signatures allow us to make a single signature that looks like a normal signature, but it actually reflects some committee that created that signature, right? So we say it's get key aggregation, which means we have a single key, and then the signatures that are made in that single key look like just a single person signed them, but they could have been from a 3 out of 5, 3 out of 3, or 1 out of 3, or whatever. Okay, so that's one aspect of it, and that's the Frost aspect. Okay, it's the but then you have another aspect where you want these bespoke conditions where you have a time locks, right? So time locks are a very particular thing. Now, you could do this time lock thing you described by pre-signing transactions. So signing a transaction that and giving it around to, like you said, a 1 of 3, right? So you as like the 2 out of 3 or the committee that has a 2 out of 3 on the main spending path could say, listen, we want any one of us to spend it after 7 days. So we create a transaction and give it to each of us, but it is encumbered by this time lock. Okay, so that will be able to be spent after some time. But another way we can do it with less interaction would be to simply put the rules in Bitcoin script. Okay, and that way we wouldn't have to remember the transaction, which is an important point, right? With this transaction, we all got to spend it after 7 days. We would have to recall that transaction, remember the signature on that transaction in particular, and store it in a database. If you lose data on your computer, whatever, you're not going to be able to take that transaction anymore. So one thing we can do to reduce interaction and reduce the storage requirement is to use Bitcoin's scripting language, but inside Taproot, right? So a Taproot key spend, a script path spend, which means we would have that script inside that public key. Okay, so the public key would look like a normal public key. It is actually being spent by 2 of 3, but in addition to this 2 of 3, it also has embedded in it a script, and this is committed to by the public key. No one can see that commitment to those rules. Okay, the rules will be in the script, especially this time lock rule will be there in the script. And so if we need to use this emergency, after 7 days spending thing, each one of us will just be able to reveal the script to and spend that output, but only in that emergency condition. If we never use the emergency condition, no one will see that fingerprint on the blockchain, and otherwise it will look just like a normal public key and a normal signature. If we use the 2 out of 3 path, but we need the emergency path, then and only then are you able to fingerprint this and say, this must be this kind of wallet or this kind of thing doing this 1 of 3 after 7 days kind of thing.
Gotcha.
On the blockchain, yeah.
That makes sense. And I like an example that's popped into mind, which is a very kind of niche example, but it's one that does come up a lot, is things like a $5 wrench attack, right? And people often say things like, if I was being threatened with a $5 wrench attack, I would just tell them that I had that Bitcoin in a multi-sig setup, so they couldn't possibly ever get it. However, if you're facing a relatively sophisticated $5 wrench attacker, you might find that they have already seen your transactions on chain, and they will know beyond a shadow of a doubt that actually you are not sitting in a multi-signature transaction. You have just a very basic, simple spend Bitcoin transaction leading to your funds. Whereas, say, in the world of Taproot, Schnorr signatures, what we're talking about now, everything would look pretty much the same. So there is some level of plausible deniability about what kind of rules or stipulations have been set to how your Bitcoin can be spent, whether it's in like a multi-sig type setup, whether there's a time lock to it. And so that's just like one niche example, but it's something for people to be able to get their heads around. It's less clear from anyone looking on chain who might even know which UTXOs or Bitcoin belongs to you. It would be less clear for them what kind of transaction rules are set around it.
Yeah, that's an interesting point. With this $5 wrench attack, I always imagine that the $5 wrench attacker would first extract from you something like the wallet or the software you use to track your wallet, which doesn't need your keys, I guess. And then they would be able to see all your UTXOs and stuff. And so the trick there is then how do you make sure that the attacker cannot see the configuration that you only use single sig, because that will maybe left in your wallet somehow, right? But perhaps not, though. We could do it. We've got to just make sure from a software engineering perspective that we keep it secret, the actual configuration, even on the user's computer, and then they themselves know it and then can bring it out when they need to spend only, I hope. Yeah,
that's a good point. Is any of that actually being worked on, or is that more just like a conceptual idea that we should probably build into it in software?
No, that's just the point that a self-note that I made to myself with respect to this, yeah.
You're very right, yeah. So are there any other benefits of, say, the Frost protocol over either other multi-signature protocols that are available right now, or even just basic sort of signal signature setups?
It is pretty much all down to the data and the privacy. That's all the advantages you get. Oh, actually, there is a new one. Okay, I'll tell you about the new one that I was just pointed out by someone on Signal, and they asked me the question, hey, so with this, you have this Unchained Capital and Casa stuff, right?
Mm-hmm.
Where they offer like a multi-sig service, and quite a few people use those things, I think. With that, currently, those guys all know all your transactions. Just a necessary part of how the outputs are constructed. Those guys have a key in the thing, right? Have a key in the multi-sig. And whenever you spend it, they're going to see, there's my key on chain, right? Even if you don't use their key, okay? So one interesting thing that can happen with Schnorr and Taproot is that we could keep every spend you make could not be visible to those guys who have, let's say we do a 2 or 3 and the third key is with them. Even though they have the third key, they can't track your transactions. They only would only be able to see the transaction if you needed their help.
That's a good point. Yeah, because otherwise, even if you're not using their node, for example, they can just follow on chain what is happening.
Yep.
And so is this something that's mainly possible via Frost, or is it something that
actually, that's a really, really good question, because the first question I asked is like, why can't we just do that right now? What is the problem? Because although the key, they do have a key in the multi-sig, perhaps that key could be somewhat manipulated, so you couldn't exactly tell unless you reveal, say, actually, guys, I need your help. This is actually your key in the multi-sig. I've just tweaked it by a bit, and it's here's how you can recover the secret key or whatever. So this is the question, and why couldn't we do it today? And it turns out that I think you cannot. Okay, I'm pretty sure you cannot, because of a low-level cryptographic detail of ECDSA. Okay, so ECDSA, it is very dangerous to sign things for other people based on without knowing the exact key, or it is So if you were to ask someone to sign something with ECDSA, and you were to say, listen, guy, this is just your key. Listen, this is your main key here, and just tweaked by a little bit. So just add this tweak to your key, and then you sign with that to help me out of my situation where I've lost one of my devices. This could actually, you could manipulate whatever you tell them to be able to get other signatures. Okay, so maybe there are more special rules about signing large amounts, and you want them to sign. You have a limit like up to 1 million sats. Then you just, whenever I request to sign, just go ahead. But if it's more than 1 million sats, you should wait 7 days and send me an email or whatever, right? So this would mean that they could be pretending to ask for the signature on the 1 million sats, but actually get a signature on a different transaction.
That makes sense. By providing a different tweak to the key that actually...
Yeah, just because of the algebraic way ECDSA is arranged. Okay, but with Schnorr, you can tell them the tweak, and the good thing is about Schnorr that the key is sort of hashed as part of the signing, and so if you tweak and you say this is your key, it'll only be valid for that key. Okay, so the user cannot be scammed by someone who's got one of their keys and is trying to steal all of their funds. In this case, they will be able to steal up to the limit the user has specified. In this case. With one of the keys, right? So that's just an algebraic advantage of Schnorr signatures that it applies to Frost. It's optimal to use this trick using Frost, because then you have your transactions look like any other transactions. So this third party, as is everyone else, is really in the dark about your wallet. They cannot see anything until you ask them to do something. Yeah.
That's right. Is the reason... I've heard a bit of trivia recently, and I just want to run it past you. Is the reason that we're now moving to Schnorr signatures rather than ECDSA, which is like the elliptic curve cryptography, if anyone doesn't know what that acronym means, is it because Schnorr was originally something like proprietary? Like it wasn't really adopted fairly early on or worked on fairly early on, because ECDSA was, I guess, kind of free and open source in the traditional sense, whereas Schnorr was proprietary or had some level of limitation.
It had a patent on it.
Patent, yeah, that's the word I'm probably looking for. And now that's kind of over, which means that it can be used and modified or whatever else, and therefore that's why we're putting it into place now. Because I'm sure this is a question sometimes people have, is like, well, if it's so good, why are we just using it now? Why didn't we start this 13 years ago?
Yeah, I think work on Schnorr signatures really did. It was a long time ago that people started working on it. What now? The question is, like, before Bitcoin, why wasn't it used? And this is the reason. Yeah, for sure. That's the reason. But if Satoshi had chosen Schnorr signatures at the beginning somehow and was like competent enough and confident enough to implement things correctly, and just violated the patent flagrantly, it could have been a good decision.
True, yeah. Hey, it would have been possible as well, being an anonymous or pseudonymous inventor.
Yeah, I don't know. Yeah, I don't know. Maybe GitHub. I don't know what patents like. Does GitHub have to remove the thing if it's using the patent or not? Or is it the users who have to get? I don't know how it works.
Likewise.
So maybe it's not a good decision. I'm not a patent lawyer, and the best thing with patents is not to put them on anything, especially not software, and especially not mathematics. So that's the big mistake.
Well, yeah, if you want things to be distributed, used, and worked on, it would not make sense to lock it down in that way. But Either
Absolutely.
way, here we are. We have Schnorr signatures.
Yeah, it was from a time, a bygone era, I think, when cryptography was. So the name of the paper that Klaus P. Schnorr published is something to do with smart cards, right? So he's like, this would be an efficient signature to put inside a smart card. When you tap it, it'll make a signature, or something like that, or however smart cards work. I don't even know what the definition of a smart card was back then. But yeah, that was sort of the idea. And patenting, a physical device, I guess, or something you use in the physical device sort of makes sense if you're trying to sell some physical devices. So give Schnorr his credit, or give him a break on the whole thing. But yeah, it turns out that Schnorr, what he came up with was sort of like this fundamental mathematical structure that was extremely useful, not just in signatures. Actually, it's extremely useful mathematical structure everywhere. Schnorr signatures just happen to be the most practical example of it, but we use it in all kinds of zero knowledge proofs as well, the same kind of structure. And so it was really a shame that he patented this thing.
Yeah, that's right. I have no idea of the history of him, but is he even still alive now?
He is.
That's good. Yeah. At least he can see this coming to fruition.
There was some drama on Twitter about him some years ago. I don't remember how long it was, a year ago or more, where he sort of claimed to have cracked RSA, but he had not. So unfortunately, he had not. People were a bit worried because he's a bit of a smart guy, I guess.
You would think it comes from a credible source. Maybe he's onto something. Yeah.
Yeah, but I think not. He made an error in his analysis. Yeah.
I guess that happens with maths. You get to forget to carry a 1 or something like that, carry a 0.
Exactly.
I'm just curious, are there other points on Frost multi-sig protocol that you'd like to discuss or tease?
No, we have a Bitcoin Sydney Socratic where we did like a big Socratic on them with Jesse Posner, who's one of the other people working on Frost implementations, and we sort of had a very long discussion about all the implications there will be for users. Probably the thing we didn't discuss is the downsides to the thing, the low-level technical downsides that make things a bit trickier to do Frost. A bit more interactivity. All the devices need to share some data up front before you do any signing. But you can do that at the beginning when you generate your key, but you sort of have to decide how many signatures you're going to want to do. Maybe 100, maybe 1,000, doesn't really matter. You can do thousands. Depending on the hardware devices and stuff. So you'll be able to do 1,000 signatures before you sort of have to recharge your batteries, your data batteries, and reshare some stuff. So there's some low-level technical inconveniences to the protocol that hopefully, from a user perspective, there is nothing at all that is more inconvenient about Frost, and it's just strictly better.
Gotcha. So yeah, it kind of has a bit more of that coordination required when doing the initial setup, and then depending on how much it's used over time.
Yeah.
How long is a piece of string is probably the answer to this question, but what would users expect in regards to, say, timeframes on seeing something kind of usable or testable? I mean, I think it is testable now already for kind of more advanced users, but say just like a general user, when would they expect?
It's not even really testable for advanced users at the moment. We did a demo of it in Gun. We sort of implemented it into Gun, but it's not released yet because we were, it was the first pre-alpha kind of thing, and a specification is sort of in the works now. First, I think we have to get the multi-sig specification finished, which is the 3 of 3, or like the without a threshold, right? So it's like a 3 of 3 or 4 of 4 or 5 of 5. This protocol, which is a bit simpler, we're specifying that, and that's going to be used in Lightning, and that's what's going to make Lightning not be identified, not fingerprint the blockchain, right? The channel outputs will not fingerprint the blockchain after we get multi-sig, because you can do the 2 of 2 that each channel requires without an explicit 2 of 2, but rather a single public key, which actually requires both interaction from both parties to spend. So the multi-sig one will come first, the Frost one will come after that. We'll probably have something in Gun before the Frost one is finished, but for other wallets, the wallets you already use, for them to get Frost will probably take some. It depends on how. Let's say by the end of the year, hopefully Frost is specified, and then depends on before the end of the year, let's say in three or 4 months max. And then it depends on your particular implementation, how quickly they can adopt it.
Yeah, that makes sense. I mean, that's still pretty close to come. I feel pretty proud, even though I didn't really do anything, of seeing the very first Frost multi-sig transaction, which Nick performed in demo at the Bitcoin Bush Bash about maybe 3 or so months ago, earlier in the year.
Yeah, that's
really
right.
Cool to see.
Awesome. Yeah.
Well, I guess people should keep an eye out for it. I'll make sure I post up info about Frost in the show notes, as well as Gun as well. And look, we can always sort of circle back to that if it kind of comes back up as a tangent in what we kind of move to next. But I figure maybe we jump into Lightning Network privacy and talk a bit about that.
Yeah, cool.
So this is a big topic. I don't know the best way to go about this, but I have some general headings and I have some subheadings. And so the general headings are general pros and cons of Lightning Network privacy versus on-chain. I've got some privacy improvements that are coming to Lightning soon that we can look forward to, as well as perhaps some practical strategies for people.
Okay,
now,
so let's I suggest instead of doing this list, let us talk about how to think about privacy first.
Yes,
and Lightning, because pros and cons are a little difficult to evaluate, but we can talk about them. We can evaluate them after we've sort of got the mental tools to think about Lightning privacy.
Absolutely, that sounds like a good way.
Does that make sense?
Yes, definitely.
Yeah. Because then you can forget about the pros and cons checklist and sort of just do the work yourself to figure out what if what you're doing is private. Yeah. So what I would like to think about first is first you have on-chain privacy, obviously. Okay. So first you have to think about your channel that you open. Where are the coins coming from, and what are the history of those coins? Okay. Your solution might be, or your approach might be to get peace of mind with do coin joins before you do it, and that maybe some users are capable of that. But of course, we've mentioned that Lightning currently leaves a fingerprint anyway, and so if you're doing that a lot and then coin joining the result of your channel again to open a new channel, you may still be obvious because the input will look like a Lightning channel, so the coin join, the output will look like a Lightning channel. And so you've got to just keep in mind, no matter what you do, there is going to be some kind of history associated with the inputs to that channel. Okay, so if you're providing the inputs. Now, once you've got a channel, let's take the simplest example. You want to purchase something on Lightning, or perhaps you want to receive some coins on Lightning. So you have a channel, and perhaps you make the channel with the person you're interacting with, right? So I want to buy a hat from the Blockstream store. So I open up a channel with the Blockstream store. This might seem like the most private way to go about making off-chain payments, because maybe you can make several payments. And then after buying a hat or whatever, you could also make payments outside, through that node to other nodes on the network, right? So, but putting aside the network for now, we have a direct channel with the Blockstream store. Now, the Blockstream store will learn, I guess, our shipping address or some other metadata through our interaction. And now keep in mind that the Blockstream store knows your UTXO history as well, right? So we can sort of seize how you got to fund the channel with them, right? So that's important to keep in mind. So they themselves are perhaps getting some, maybe they do the full KYC stuff. So probably they ask for your name and stuff. You can give them fake information or whatever, but you wouldn't need a delivery address. And so they're saying that someone who wants to get something delivered to this address had this coin history, okay? And that probably the Blockstream people are not going to use that for anything whatsoever and delete that from their servers as soon as possible. But you could imagine that if they were malicious, that they could be working with others and to tell others about what this information, what your coin history is. Someone who gets things delivered to this address has this coin history, and they can go back and sort of work backwards and sort of try and heuristically identify your wallet based on that, which is a really strong bit of metadata. Okay, and I want to keep in mind there are a lot of other things to do with privacy to do with that, but we're not putting the network. We're pretending like we just don't even have a Lightning network. We just make channels with people and do things directly with them in our channels. So the Lightning guys will learn our coin history. So let's bring in the network side of things. So let's, rather than make a channel directly to the Lightning people, the Blockstream people, pardon me, we make instead a channel to some kind of routing node on the Lightning network. And now the first thing we've got to assume here is what we're going to do is create a channel that is not advertised. Okay, so the Lightning network has a kind of a routing table, if you like, or they share each other's channels with each other. Each node, when they create a channel, if it's a public channel, they will, or an announced channel, they will tell everyone else about it so that their payments may be made through that channel. Okay, so we're not going to do that though. We're going to make the Blockstream store has, let's say, announced its channel, but with some, let's say, directly with the node that we're opening a channel with. So we node will be able to make a payment straight through this node, straight to the Blockstream store. And we have not announced our channel, so we've kept our channel secret. And let's pretend additionally that we're in the future and we're using multi-sig, so no one can see our channel on chain. It looks like any other output, right? So any other Schnorr output. So let's just assume that. Though that's not true for now, it'll be true in the future. And so it's best to think about things and not bring the complications of being able to see the Lightning channel, fingerprint it on the blockchain. So it's hidden. It looks like any other Schnorr transaction. It's going to some address, but it's secretly a Lightning channel. Okay. So is your privacy better in this case than it was before when you had something directly with the Blockstream store? Well, let's think about it, right? So I now make a payment for my hat to the Blockstream store. Now the hat is worth a certain amount of Satoshis. Now the Blockstream store does not learn my channel, my coin history, right? The node that I open the channel with does though. And they can tell also that I just bought a hat because the hat is that price at this moment, right? If they were very active, right, on spying on me. And so they now actually, our privacy got a little bit worse, I would say, unless you really want to hide stuff from the Blockstream store, right? So, but now the Blockstream store knows that someone got a hat to this address, which is not leaving it on chain. They're not getting on chain information, but they know that someone at this address is a Bitcoiner. Now this node does not know the address, but they do know the coin history, and they know that someone with that coin history is buying a hat from the Blockstream store. So it may have gotten better. It definitely did get better if that node is not leaking your information to anyone, or if that is not run by a chain surveillance company, right? But if it is, then probably things just got worse. So you still have to make some kind of judgment about who you open channels with. Now, the other thing is although the privacy definitely got worse for the Blockstream store, right? Because now the Blockstream store is sort of leaking some purchase. It knows that a hat was bought on this date. This no intermediary knows, because you've introduced an intermediary there. Now, this may not be important information, but it's sort of just, this is the mental tools you should go through when you're thinking about how you're set up and how it relates to other people. Like, am I getting more privacy this way or not? So this is something now. This is something to think about. Now, if we move forward, it's like, how can we get more privacy? And this is the point I want to make about the Lightning Network here, and this is a crucial one, is that you kind of get more privacy by introducing more intermediaries, right? So if I introduce another intermediary into the thing, and instead of paying just through one intermediary to the Blockstream store, I have two now. Well, the intermediary, the first one I pay to, does not know it's going to be a hat, because it doesn't know that it's going to the Blockstream store's channel, right? So it could just be something else on the Lightning Network that happens to be worth the same amount as a hat, right? So it's sort of, now we've improved our privacy by introducing more intermediaries, right? And that's the crucial thing, is the longer the path, potentially the more privacy you get. Probably the most important thing for your privacy will be how secret the people you have channels with, or how private they keep their information. Do they, follow best practices, delete their payment information with payments, right? Or when they close channels, they're making sure they have an implementation that deletes that stuff once it's gone, and they're, just not run by a chain surveillance company. Please, that's probably the most important thing. Open up channels with people who do not run chain surveillance companies. Okay, and then if you and the Blockstream store both do that, then you're doing pretty well. But either one of you doing that, succeeding at that, will be beneficial to probably both of you. And so that's probably the main thing, is that the more intermediaries you pass through, the more expensive it is. And also, the other downside of that approach or that situation is that it's more likely to fail, right? The more intermediaries you pass the payment through, the more likely the payment is to fail.
So it's like a trade-off with convenience versus privacy, which is, I guess, the age-old spectrum for privacy, really, isn't it?
Yeah, well, yes, sort of, but maybe we can do better. So this is if I were to lead into research, that's where I would lead into. So potentially we can get rid of this trade-off in the Lightning Network and not make it, no hops improve privacy, but make payments reliability independent of the number of hops, or not the privacy not dependent on the number of hops you do. And I guess I don't want to say like just route your payments through a bunch of hops to get more privacy, because actually after a point, the more intermediaries you introduce into the thing, the worse your privacy will get, just because there's more intermediaries that knew about the payment, right? So it's sort of like the most important thing is that the nodes you open channel with are not leaking your information to chain surveillance companies, not selling it. And probably that's just the most important key thing. But think about, apply this thinking when you're thinking about your Lightning channels and the payments and the privacy. What is the character of the privacy you're actually getting? It's sort of like if you manage to route through somebody who does not if you keep your channel unannounced, and all your channels unannounced, and that's probably, when we go through the practical tips, probably that's one of keep all your channels unannounced. In other words, you have a user kind of Lightning channels that you use to make payments, and you do not announce any of the channels on that thing. You just, like, your personal funds that you're using to make payments, keep them all unannounced, and make sure they're all with nodes that you speculate are not leaking information, and you can do pretty well with that, I think.
That makes sense. And I guess kind of reflecting on a couple of points there that I can kind of extract is that, if you have multiple parties in your route to the Blockstream store, for example, you are distributing the trust to some degree that you're not being monitored. And it also makes it more difficult for them to piece together how much is being spent to whom and for what. But the other point there is that the more people that you have involved, well, the more likely there is going to be someone on there that is surveilling for malicious reasons or otherwise. And of course, if you have a couple of those people or actors in that chain that you're routing through, it gives them a chance to kind of correlate your data a bit more reliably. Does that kind of make sense? Like the more malicious people that you have on your route, the less private your transaction is going to be. So you don't want to just keep adding more and more and more hops to the route, because you're kind of, probability speaking, adding there to be a more potential malicious actor that can then perhaps even corroborate with another malicious actor to correlate that information.
Yeah, this corroboration is a bit of a problem as well, because essentially, like, it's the same as just sending through a single malicious actor directly to your target if both the first hop and the last hop are malicious. So all the ones in the middle don't really matter after that. So that's what I would probably say, is that you don't need to just send things through multiple hops. 2 hops is sort of good in general, because in case one of them is spying, the second one maybe not be spying. It doesn't really help too much after 2 hops, I would say. If the first and the last are, malicious, you're in trouble. There is some proposal that we can improve that, with Lightning going forward with Schnorr, by making the payment hash different at each hop, using the PTLCs instead of HTLCs. You probably have heard about that. I'm a little bit skeptical that this is actually going to improve things, and skeptical that it is not introducing new attacks. So I have a page on Bitcoin problems about that. The reason is that, if the amounts are the same and the time locks sort of are correlatable, you can still make a pretty good guess about it, even if the payment hash is not the same.
Yeah.
Because obviously, or you can change things, but if the thing you're buying is still that much money, well, sort of can correlate it with each other. Each hop, the first and the last hops can still say this is probably the same payment.
That's true. And I guess a parallel for people to look at it, I guess it's not even a parallel, it's a direct thing. So if anyone is aware of things like correlation attacks or timing attacks on, say, the Tor network, like if an entry and exit node are captured, all of a sudden the data being transferred between the two can be correlated, or even the fact that someone is capturing some of that data, they can do timing attacks to find out like where you are in the world, geolocation, that kind of thing. The same thing really applies to the Lightning Network because it uses Tor routing to get through the nodes in the first place. So if anyone's aware of that attack vector for the Tor network, the same thing applies to the Lightning Network as well.
Yeah, I think that's just a really good analogy. I mean, it depends on how well you understand Tor, but yeah, the Tor and Lightning have similar trade-offs in that Lightning actually has some extra attacks that you cannot do against Tor. I'm sure there are Tor attacks against Tor that you can't do against Lightning too, that are specific to the TCP/IP stack and how things work. But the one the one that happens with Lightning, which has happened more recently, is I mentioned you should keep your channels unannounced, right? But some people have been tricking Lightning nodes that are, let's say, intermediaries to revealing their unannounced channels just by trying to send payments to the unannounced channel. And the intermediary there will, sort of give a different error depending on if the channel exists, like does dummy payments, and will give a different error if the channel exists or does not exist there at that node. And so you just sort of make a bunch of payments to a bunch of different nodes trying to find out where that unannounced channel actually is. And so that allows you to figure out where the unannounced channel is and then potentially better understand what you're doing and where payments come from, and then get more information about use the on-chain. That's something we probably haven't talked about. How do you link the on-chain heuristics to the off-chain heuristics? But hopefully, anyway, the point is that these attacks, practically these kind of attacks exist at the moment. People are fixing them. Okay, so they're going to be fixed, and hopefully these error messages and stuff, it becomes much harder to find the unannounced channels. And if the unannounced channels are, Taproot Schnorr channels, then they look like any other thing on the blockchain. So hopefully it becomes more difficult to discover them. But there is problems with the node, this node that you have the channel with, the coins that came into that channel and that settle out of that channel. The node will probably use those coins and make a new channel that may be public and announced. And then if you had a theory that this channel, this UTXO happened to be your Lightning channel, right? Or happened to be a Lightning channel, they can sort of confirm this theory by looking at what happens with the coins after that, because then the coins get settled out of that channel, go into that node, a new node's channel with one of the routing nodes channels, and then they announce that and say, here is a Lightning channel. And now you can look at the history of those coins and say, that maybe perhaps the coins it came from was also a Lightning channel, right? And so that exchange or whatever, who is working with Chainalysis, who has provided those coins to you to fund your channel, can say, this guy's using the Lightning network. You need a license to do that or whatever. I don't know if it happens to you, but I get exchanges emailing me and threatening to close my account because I coin joined before going into them. And also if I coin join after withdrawing from them, they also threaten me. So maybe that becomes a thing with Lightning in the future. We don't know where we're going with this thing. Yeah.
That's right. How dare you look after your privacy in that way? That's it's horrible.
Yeah.
I think like all the points that you've touched on there really are reflected in the kind of take-home points that I was going to rattle off. So I think that's really good as background in terms of then getting our head around some kind of these aren't strategies as such, but I think they'll lead to strategies. I might just rattle a
I
few.
just want to make another comment on that thing. It's really important. That's probably you can pretty much separate Lightning concerns, privacy concerns, into two separate categories. One is cross-layer links. So you've got layer 2 funds, but they somehow get linked to the layer 1 funds. And the layer 1 funds privacy is not good. And so then the layer 2 funds privacy ends up not being so good. That's probably like the first category. And we have some proposals to fix that a bit, to stop talking about channel IDs. So when you send your payment, you're actually sending it through particular channels, and you're actually sort of saying, which UTXO on chain, which channel on chain should be used to route this thing to the routing nodes. This is not so good. This is really bad, actually. You should just be saying which node you have to go to next to send the money, not which actual on-chain point should you send the money through. And this is sort of the reason these attacks can exist, because when you send these probing attacks, because you send and you say, I want to send money to this, send an HTLC to this channel ID with this, this UTXO, and you can even tell probe whether a UTXO is a Lightning channel, maybe by sending it around to a bunch of people and saying, I'm sending a payment to this guy with this channel, and may not be a Lightning channel. And if none of them respond with a certain error, or an error that indicates that it exists, then you say, oh, maybe that isn't a Lightning channel. But if they do, then it is a Lightning channel. So this is called a cross-layer link. We've got something in the layer 1 that is leaked into the layer 2, and we don't want that thing there. We want layer 1 to be layer 1 and layer 2 to be layer 2. Once the funds get onto layer 2, they should be uncorrelatable to the layer 1 things. So it's removing those links at the protocol level, so we don't tell people about which channels to use, really would improve things a lot. And so the problem is it becomes hard to make a network like that, because you're what if I just go and tell people I have all these channels to all these people, right? And I didn't have any. So the reason the cross-layer link exists is to prevent denial of service, to make sure the things actually exist on the blockchain before you tell other people about them, so you don't spam everyone. So it's actually a denial of service concern, nothing to do with the actual operation of the Lightning network, if everyone was honest, right? That's one point, is we have these denial of service concerns that lead to privacy being lost. But maybe we can defeat the denial of service in another way without losing privacy. The other thing is, the other category of Lightning privacy is the payments by themselves, right? So this cross-layer link problem does not let you make payment. It does not let you identify payments, but it does let you identify channels. And also, those channels are associated with nodes, and those nodes have IP addresses. So it can be even worse than these cross-layer links can make privacy on Lightning even worse, especially if you use an announced channel, than privacy with just on-chain funds, because now they also know your IP address, right? Because you've told them this is where my Lightning node is, if it's not behind a Tor hidden service. So that's the cross-layer link thing.
That's right.
Does that make sense?
It absolutely does. It allows all sorts of process of elimination to be undertaken by someone who wanted to surveil the network. And some of these things are necessary, because you're right, it prevents like a denial of service attack, or even things like channel probing will allow you to be able to send a Lightning Network transaction without it failing frequently, because it's already probed the route to say, like, will this get to where it needs to go, and how much is it going to cost? But of course, the downside to that is that allows things like brute force probing type attacks, where people then can glean things like channel balances or discover private channels, especially if they have a lot of information of the publicly announced channels that they can just remove from their data set, as well as all the 2-of-2 on-chain transactions, which they can kind of then factor in to say, these are probably the kind of UTXOs that I want to query. And all of a sudden, it's like they have a very workable data set of only like a few thousand channels to probe or UTXOs to look for. Yeah.
Mm-hmm. Yeah. So that's this cross-layer links is really a key issue, because instead of defeating chain analysis, we are saying kind of enhancing it.
Yes.
Depending on how you do things, and making if your channels are unannounced, and we have Taproot and Schnorr and multi-sig 2 being used, then things are quite a lot more difficult, but still they can still enhance their chain analysis to some extent. Now, the point of doing chain analysis is to identify particular payments, right? Not just like clustering addresses together, right? And so Lightning, the advantage you get, although you somewhat enhance chain analysis, right, depending on how you do things, will hopefully not let them identify particular payments. Okay, so yes, you've enhanced chain analysis, but you haven't necessarily leaked more information about your payments. And that's a really crucial thing, right? Because the whole point of defeating chain analysis is, not making sure they can't see who you paid and how much you paid, right? And so if you somehow enhance their heuristical tools, but you still make your payments private, then, that's a good thing on net, right, for you.
Absolutely.
So that's the other category is identifying payments actually made. We've talked a bit about like how to think about how the parts of the network will see the payments. And so it's sort of like try and do your best with making sure the people you have channels with are keeping your unannounced channels private and keeping up to date with their software so they don't have these leaking this stuff and themselves not run by these chain analysis people, right? So if you do that, but there are still some ways to identify some payments being made. For example, even if your guy is honest, we do the balance probing attacks like you just mentioned, right? To figure out what the balance is of the channels. And because when they change, then a payment has been made through them. So if this guy manages, we mentioned, right, let's say we have an intermediary node with the Blockstream store or even if we have a direct channel with the Blockstream store, like let's say we have a direct channel with the Blockstream store and we can make a little transaction privately, right? The Blockstream store is keeping everything private, and we've updated our channels, but the balance has changed, and perhaps this information can leak to someone. And what they do is they pay me, they pay whoever's paying the Blockstream store. Let's say it's me, and they pay me different amounts, and they try and see what will go through my channel, right? If they could see before what would have gone through my channel, can they, see it afterwards? Now, it shouldn't work in practice, that kind of attack. But if we add because your node will just flat out reject the payments and not leak information unless there's a bug, right? Unless there's an implementation problem or something that they leak the balance, even if they're the destination. But if we do an intermediary node and do probing from there, maybe we can see that the balance changed on my channel to the intermediary, and the balance changed on the intermediary's channel to the destination. Now, in order to do this, I think you will need to be a routing node. Like your node will be public and be a routing node. Or as I said, I think that in theory you would need to do that, because otherwise your node will just reject stuff it doesn't know about. But you can see if this is why the unannounced thing is probably important. But you can see how if there is errors or ways to differentiating things with errors, you can also leak that information and figure out what a payment was made, even though we're not involved in the payment. So that's another thing that has to be gotten right. Let's say is this stuff.
That's true. I want to maybe
even let's say just the furthermore, like the Blockstream store, he has a public channel and does route things, and so people are going to be able. You should be able to, if you can do an effective attack there, regardless of error messages, just by checking the balances, you should be able to tell when someone bought a hat, if not who who bought it, just when they bought certain items from the store, right?
That's right. So I guess we could say on the sender side, there is, with these caveats in mind, making sure that you're choosing intermediaries to route through and multiple intermediaries rather than just directly routing or having a channel just with the place that you're trying to, say, send money to. There is generally...
Having a channel directly is pretty good, except it can be bad in the case that they are the company, like malicious. So you have to sort of make it a decision, like... a worst case scenario, right, is illicit drug marketplace. Okay, having a channel with them is very effective, except for the cross layer links problem, right? So if you look at the coins that come out of that channel will be linked to them, depending on how well they manage those links, because they will then go and sell the coins, and then they will get linked back to your coins that went into the thing, and so perhaps because of that problem, it's perhaps not a good idea to make it directly. But let's say somehow you can get rid of that problem, make a channel directly with them, and then their coins where they coin join or do something really special before they sold anything on an exchange, or maybe they never sell. They're hardcore hodlers and they just sell the drugs to stack sats. Even if you had this assumption that would be good, but what if it's run by the feds themselves, right? And then you're totally screwed. And so the point of bringing intermediaries is you have to sort of decide whether you want to bring in intermediaries, right?
That's right.
And usually it probably will be the right decision, but you still have to be careful. In the case of the Blockstream store, probably what you're buying is not too sensitive, but also they're very trustworthy there at the Blockstream store, I'm sure. So it's sort of like doesn't really matter so much. But other things you have to sort of like, what is the destination? How much do I trust it? And how important is it that the thing is private? And you have to sort of weigh up there. Probably the right answer is to use two intermediaries most of the time.
And as you mentioned previously, even trying to do something like a coin join or a coin swap before opening the Lightning channels in the first place, just to create a bit more of that disruption of the link with your past on-chain history. I guess another thing here
That's the two things to think about, right? Keep the cross-layer links. Make sure you understand the implications of your cross-layer links.
Yep.
Before you make payments, because that's the big thing.
The other thing here that we haven't sort of said specifically, but I think it's sort of implied in what we're talking about, is that when you're running a Lightning Network node I guess that's it. You don't rely on a third-party node, or if you do, be aware of the privacy trade-offs. Because with a lot of what we're talking about, you could have really good cross-layer links looked after in terms of coin joining or coin swap before you open a channel. You could implement a couple of intermediaries, which you seem to feel like are trustworthy enough before that final point. But at the same time, if you're using a third-party node, they know the majority of that information as it is. And in fact, you probably wouldn't have as much flexibility about whom you open channels with and so forth. So I guess a big privacy improvement probably off the bat is running your own node rather than relying on a third-party custodial node. And that gives you a bit more flexibility and more privacy, depending on how you use it. Yeah.
It's so like, it depends on how much you trust those guys. That's the thing. Like, So I think running your own node is absolutely necessary for the network to exist, right? But you have to sort of say, like, if you run your own node and you do it badly, okay, you set up your channels badly and you're not like taking care in this, and you're making really privacy sensitive payments, right? That's the other thing. Like, most of the people listening to this are not making illicit payments, right? So they're taking this approach where they sort of just use VPNs and stuff to reduce their fingerprints, to reduce the amount of data like that can be dragnet harvested by people. I think that's people's most words. They use their Calyx OS on their phone, maybe, or they're looking to do something like that and reduce they're using Proton Mail instead of Google or something, or they're running their own mail service. They're really into it. And they're trying to just reduce just do best practices. And this is the running your own node would be kind of like a best. I'm not 100% sure it's like a best practice in order to get the optimal, right? The optimal privacy. Running your own node is there. But if you happen to agree that like people who like Async, who run the Phoenix wallet, which I've heard good things about, are not giving away your data, and you just want to, reduce Chainalysis stuff and people getting your data, then as long as you trust them, then that is actually a good way. Now, of course, it's don't trust, verify. But if you take things into your own hands and you just like, let me route through this node, and they happen to be run by a Chainalysis company that is like advertising low fees or whatever, you may have goofed yourself. As opposed to Async, where if they are doing what they say they do, right? Your outgoing payments will not be linked to you in any way. It'll be made through an intermediary that is making a lot of outgoing payments, right? So it's really difficult to correlate anything to you. And incoming, it's also receiving a lot of incoming payments, which will also just go there from everyone else's view, will just go to Async.
That's right.
Right.
Sorry, you go.
Yeah. So, and they will also be more reliable. That's the other thing, right? So the payments tend to be reliable there. So there is a big win if you can find an intermediary that is not a chain analysis company, is not using your information against you. Now you need, and the thing is, even if you're doing that, running your own node, you still need to find those intermediaries. You just have more control about what you're giving them and when, right? That's and more and better privacy if you're on chain coins, because you're going to probably I don't know how Phoenix Wallet works, but it or the Phoenix Lightning node on your phone works, but I'm guessing that it using their own kind of Electrum servers or whatever. That's how these things usually work, and so you're also giving your coins to them. If they have an on-chain, if they couple it with an on-chain wallet, so it's like you're putting quite a bit of trust in them, but you also are putting trust in random people that you open up channels to, especially if you don't know what you're doing. Okay, but you have more control. You can get the optimal Lightning privacy experience only by running your own node. But if I'm just talking to someone who doesn't know what they're doing and just wants and reckons that one of these companies, Breeze or Async or the Blue Wallet or or a fully custodial one, if they reckon that those guys are willing to take a bet and they don't have the time for it, I would think it's still a good idea to probably use a custodial or semi-custodial wallet at this point, because the number one reason is payment reliability, which we haven't really talked about, right? We talked a little bit. It's like there's an opposing there's a trade-off there, which is not great. And so you really want payments to work when you're using Lightning, because it's kind of the point. And so make sure if you do things yourself, you're in charge of your own privacy, better control, but you also have to make sure your payments go through. Otherwise, you won't even be using it. And then the tool has lost its purpose completely. That's my sort of thinking on that.
No, you're absolutely right, because there can be that false sense of security of saying, well, I'm running my own node, so it's private, right? And it's like, well, it's a very big statement, and not really, because it's like, well, have you made an alias really clear that people can track you by? Are you using Tor or not? Or what about your network privacy beyond Tor, like VPNs? But also all the things that you just mentioned in terms of like, well, who have you set up your channels with? And are those trusted enough? And do you know that they're not chain surveillance companies? I would say for beginner users, it might actually be far better to go with one of these sort of custodial or semi-custodial type wallets, because then at least if you're trusting of that service, like an Async or Breeze or something along those lines, you get a lot of the privacy benefits on the sender side of Lightning, which is generally speaking better for privacy than, say, the receiving side. So yeah, that's the good takeaway points. One thing that we haven't mentioned yet, but I think it's sort of implied in what we're talking about in the ability to probe channels that are unannounced, or the ability to see public channels because they are announced, is that on the receiver side in the Lightning Network, there is kind of very little privacy, because when you share an invoice, you're actually giving away on-chain data, because the invoice itself will normally have things like your node alias, the IP address of the node, the channel ID. Essentially, that helps people then find a route to your node so they can pay you.
Yeah, does it have the IP address? I don't remember that, but it definitely, it has the damn channel ID, and that's the cross-layer link we talked about. That's a really bad one for the receiver. You have to get rid of that one. A node would be fine. I mean, you're going to need to say where it has to go. So the node or some key will have to be identifiable, but maybe there could be ways of just having like every single payment has a different what you want to do there with the payment, like, because when you create those invoices, like I'm guessing with Phoenix, the node itself will not be your little node. Actually, it will probably be the Phoenix node. I hope. Like, that's the way I would design it if I would design such a service, right? So that's how you get receiver privacy, is you get the node that it says to send to is really not the terminal node. It's a node that you have, an intermediary you have in front that receives a lot of payments, and they then forward that to you because there's something in the onion that will tell them. I don't recall exactly if that's possible right now, but that's the way things should be done in theory. I work on the theory, not on the practice.
I think that's exactly how that works. Yeah, is okay. That will be from the perspective of the spender, that will be the terminal point. But then async will receive it and know that this belongs to your wallet node, and then will then forward it onto you instead. And if a channel's not open, they'll cover that essentially. Yeah.
Oh, that's good. Good service.
Look, another weird thing that sort of popped up for me recently that I thought, I don't know if a lot of users are aware of this, is when they reuse Lightning invoices, which, like, obviously a Lightning invoice, the way that it works, or the way that it's kept secure, is that there is the pre-image that once the payment has been sort of comes to almost fruition, that pre-image gets shared. That's like the secret that lets everyone collect their routing fees along the way. And of course, for the receiver to like unlock their Lightning Network transaction that they've just received. However, people can sometimes, they will sometimes post it up on things like Twitter, and then they'll reuse that same invoice. And my understanding is that if there is a node or an attacker, sophisticated enough that can see that, say, second or third or fourth transaction that's reusing the same invoice, they could essentially take those funds. Now the technical nuance of this is sort of lost on me a bit, but because they would more or less have access to that pre-image, that secret that's been used previously when the invoice was first derived. I guess we don't need to go too much into the technicals of that, but for anyone listening, it's probably just good to know that an invoice on the Lightning Network should really only be used once if you're receiving. You shouldn't kind of keep reusing that same Lightning invoice over and over, even if you think, but it's for the same amount and I'm using it on the same day or something along those lines. It's like that's sort of defeats some of the purpose of the security built into the Lightning Network to make sure that the receiver receives their funds and everyone along the way gets paid the correct routing amounts.
Yeah, the thing is, I would like to make a point there that it's not a theoretical limitation, though. We could have invoices that you make as many of them as you want. I think it's just, I'm not sure what happened with that specification, but it was called spontaneous payments. I think Rusty was working on it, but you can do that. I don't know. I can't remember all the details of it, but yeah, like theoretically, it's easy. I think it should be easily possible to make an invoice that multiple people could pay the same amount or a different amount if they wanted to, and still get proof of payment for that thing. They will go, I paid this much, money, and maybe you send them a message in the Onion where you send this extra data and you say like, I'll pay you, 1 million sats to sign this message. And maybe the message is, I donated 1 million sats on this date, right? And so you could send whatever message you want and pay for the signature. It'd probably be beneficial to have PTLCs to do this, to actually get the signature that you could prove to other people. But the point is that you could get, probably you do need that. That's maybe the reason we don't have. So theoretically, now that we have Taproot Schnorr, we can actually do that. We probably couldn't do that before. The specification yet to be written, I think.
Gotcha. Yeah, but the capability's there. And look, that's probably a good segue as well, because we've talked a bit about the issues with Lightning Network in regards to privacy and that convenience trade-off. Some of the more, conceptual ways of looking at it, like you've mentioned, those cross-layer links. And so we know a bit about the problems. And so I'm curious, like, what are you aware of that's coming down the pipe in regards to solutions to those problems? Or even if you've got one that, you're either working on or kind of theoretically trying to figure out, maybe we'll sort of throw that in there there's some solutions down the track, basically. Yeah,
so the way the Lightning work is specified now is like hasn't taken advantage of all these things. And there's a lot of room to grow and improve on all kinds of things, especially payment reliability, which is one of the things, like, I don't think, for me as a user, the privacy thing is not as important as my payments always going through. I don't know how others feel, but that's the most annoying thing for me when the payments doesn't fail, so doesn't succeed. So we have improvements to be made there. There's improvements to be made in privacy, and all of them can be done with the current way the Lightning Network works. And I'd like to say before as I criticize things, I don't even put work into the Lightning Network in terms of actual coding effort. And it's incredible that first of all, it's incredible that Bitcoin exists, but it's incredible that we've actually, that those people who dedicate themselves to the Lightning Network have created a layer on top of that fantastic first invention that is just enhanced it. And it's just, I'm unfathomably grateful to those people who work on it. Now, I must say that before I criticize things, but my job, my only contribution is criticism, right? Because I work on the theory, what it is and what it could be, right? So it's like, this is like this, but it could be like this. And so the solution I am preferring, that I am working on the theory of, is a solution that's it's been suggested quite some time ago. Okay, so it's not sort of new, just that the actual practical way of implementing it is not efficient, is not practical. So if you Google up, there's a paper called Tumblebit, which was the first payment hub proposal. Okay, and a payment hub is kind of like this intermediary that we have in the Lightning Network already. And one thing we haven't talked about here is that the Lightning Network has kind of already progressed into a kind of hub and spoke architecture, right? I think everyone acknowledges that, where there's going to be some main routing nodes, and that people are going to use those because they're well connected. And the more well connected a single routing node is, the better it is as a person to make a channel with, both for payment reliability and for privacy, because the more payments going through that thing, the bigger anon set you have, basically. Does that make sense?
Yes, absolutely.
Yeah, so this is hub and spoke. I mean, the hub is the central hubs, and then all these channels going into them. There'll be a few popular ones, and the rest, you can always connect. It's permissionless. You can always create your own channel, and people could always make channels with you. But it doesn't really make too much sense to have this really spread out Lightning Network where everything goes through a whole bunch of hops. It makes sense to have these hubs, and they're all really well connected to each other, a handful of them, and then we connect to those. Now, if they start censoring transactions or misbehaving, we can always move to a new hub or to one of the existing hubs, there, and get rid of this hub from the network, right? So it's not, it doesn't mean, it's not, centralization here is not actually a bad thing at all. In fact, like most things, the centralized version is much, much better than the decentralized version. If you've seen any attempts to make decentralized Twitter or decentralized, Uber or whatever on the Ethereum blockchain, it doesn't really work. And so the reason we have decentralization in Bitcoin's layer 1 is because we have specific properties that cannot be achieved without decentralization. Okay, but in Lightning, we can actually achieve those properties with like a very large degree of centralization. Perhaps. Okay, perhaps. Okay, now it depends, right? You centralize, there's less parties less parties you have to corrupt. Like if you're a chain analysis company, you can get one of the popular hubs and you become one of the popular hubs, and then you sell your data behind the scenes to the NSA, whatever. So that's not so great. And then you could corrupt other ones by threatening them because they're large and they're probably easy to identify individuals running them. So there is certainly not, centralization is not a panacea, but the most important thing is that we could scale the Lightning Network to have a lot of people using it with a lot of centralization and a lot of payment reliability there. Okay, but there is this privacy problem, right? Centralized hubs that try and censor payments are not going to work, but centralized hubs that spy on you and sell stuff to the best paying government, maybe they would work. We can't sort of exclude that. And the fact that the threat of that possibility means that people try and sort of decentralize things to the point that their payments don't go through very well, right? And so this is we want to remove this conflict between convenience and privacy. Okay, so what we imagine in this Tumblebit paper imagines is something called a payment hub. And a payment hub is like just a Lightning intermediary, you can think, but it instead of getting privacy by adding multiple hops, right? By adding a second hop, you get privacy with more privacy than you would have with multiple hops with a single hop, under some assumptions. Okay, so the idea with a payment hub is using some tricky cryptography, we can have a payment go through it without the payment hub being able to link the incoming payment to the outgoing payment. Right now, the payment is linked, right? So in Lightning, you say the payment goes in, and you say, I want this to go to this guy, this channel ID even, right? With the cross-layer link there. So you say, I want to go to this channel ID. So the incoming is totally linked to the outgoing. It knows that this node was paying through our node to this other node, at least. What if we could say that this incoming payment comes in, but it doesn't tell you where the payment is going, but somehow via magic, a payment could be unlocked on the other side, going out.
Like a blinded coordinator kind of situation?
Yes, right. It's almost the same idea as a Chaumian bank, right? Or a Chaumian eCash.
eCash, yeah,
Chaumian.
that's right.
So a Chaumian mint is where you can deposit some coins and then you later withdraw the coins, but the withdrawal cannot be linked to the deposit at all, okay? This is a very powerful thing, and I actually expect if payment hubs didn't exist, we would still, using eCash would be a fantastic thing to do on layer 2. Just like I need to make a payment to this guy. Okay, so I buy some eCash from you with a channel I have with you. I buy some eCash, then come around and tell you to send the payment to this guy. Now this gives you very, very good privacy, but it has custody, right? So this Chaumian mint there in the middle is holding on to the funds before you send them through. So what a payment hub is a Chaumian mint except without the custody bit. Okay, so that's what it is. So instead, how could that conceivably work? Let's start with the payment instead of in Lightning, the sender creates a HTLC or in the future a PTLC first, going towards the intermediary, and the intermediary sees that and sees that it should forward it to this next channel, and that links them. Okay. With the payment hub, what happens is the coins go out from the hub first to the destination. Okay, the coins go out from the hub first destination, but they are locked, similar to a Lightning payment is locked. But the secret is not owned by the receiver of the coins. The secret is actually owned by the intermediary himself. And so then what the receiver is given a sort of a challenge to solve, to unlock the coins. And in order to they will purchase the solution to that challenge by giving the challenge to the sender, and the sender will purchase the solution. But when they purchase the solution, the purchasing of that solution cannot be linked to the challenge itself. Okay, so the sender will purchase that solution and then give the solution to the receiver. The receiver will then unlock the coins. Okay, does that make sense?
It does, yeah. Yep. And I'm guessing we're using cryptography essentially to basically issue the challenge without kind of giving away. Yeah.
Exactly. So the problem with the cryptography in Tumblebit is it's a bit too complicated and time-consuming and computationally intensive to make it practical. It also relies on cryptography you don't commonly, or cryptographic primitives we don't use in Bitcoin already. So it's like you have to write these new libraries and everything, and get people to use them, and create rather complicated wallets that use all this complicated cryptography with all these new dependencies that they need to complete the task, and it's slow. A big problem with it is that you can only use if you want to make a payment, they have to be in like uniform amounts, similar to
like an equal
coin
join. Yeah,
exactly. Similar to equal output coin joins. So this is a major drawback of that paper, but it has been refined. So better ideas have come out, which allow multiple, whatever values you want. Similar to a Chaumian bank, you can deposit, 2 Bitcoins and withdraw 1 Bitcoin, withdraw half a Bitcoin into a payment, and it doesn't. The bank cannot link the two things at all. It cannot even tell that you originally deposited 2. All it knows is that you are taking out half a Bitcoin now, and you have no idea how much you have left, and maybe that's all your Bitcoin that's gone. The bank has no idea. So we can actually do that with payment hubs in a paper called A2L or A squared L that came out. But the problem with this A squared L is that the cryptography is too complicated and it's a bit slow. It's still complicated. It's a bit much more elegant, but it still uses cryptographic primitives that we don't use in Bitcoin. So we have to introduce all these new libraries to do it. And actually the libraries themselves don't exist. They have yet to be written to do that thing in languages like Rust. There's some C libraries that maybe you can do it, but it's really, really bespoke cryptography. And it's very, we don't really know how really secure it is. It's something we can sort of, is not really a good foundation to build this on, I'd say. And so what I'm working on at the moment is doing this thing with sort of normal elliptic curve cryptography. And that's what I'm excited about. But if we could get that to work, you can imagine that this centralizing force that already exists in Lightning can be allowed to go on unhampered because it no longer has an effect on privacy. In fact, even if a chain analysis company is running this hub, right, but they have a lot of people making payments through it, they can't link the payments, so they're just actually helping the network. They didn't harm the network. Now would probably be good. There are some statistical analysis that you can do, right? If someone is in a rush to make the payment, you can see that they, a payment comes in of some amount and and can be linked to the outgoing payment via the amount and the timing of it, right? Although they cannot link the payment itself does not link it. The amount and the timing of it might say that those two things are a little coincidental. There are some cool tricks to get around this, like the outgoing payment could be made a year in advance, or a shop like the Blockstream store may take outgoing payments to himself, right, from the payment hub, which as I said, the payment hub creates the outgoing payment first. So it creates a bunch of hat payments, right, or for each of their products first, and then eventually someone comes to buy it, right, and they buy the unlocking for it. But there's no real way to link the two except via the amount, right? The timing is then solved, but the amount is not necessarily solved. But there are other ways of tricking this. So you could pay for several different things with one payment and unlock several payments with one, and then there would be very difficult to link these outgoing payments that are not timed together with this single payment that comes in and unlocks several of them, right? If you're sort of batching your payments together to buy from multiple different shops, you're sort of adding things to cart from multiple different shops or whatever, and then you click buy in one go, it buys them all. And now the payment amount no longer links very well. You can also pay for one large purchase. Let's say you're buying a car or whatever, with several payments coming in that would unlock that and others. And there are more tricks than that, but I won't go into them, but you hopefully get the idea.
Go ahead. I was going to say, it reminds me of, say, like, rather than a Tor-based protocol for sharing data or transferring data, it kind of reminds me a bit of like mix nets or something along those lines. Well, not quite exactly the same, but, in terms of, splitting up the transactions or delaying the transactions significantly in between, whereby, that correlation attack of the amount and the time becomes just sort of infeasible to actually track and kind of too confusing, because there is enough other transactions that don't have a perfect correlation in regards to the amount or the timing of it.
Exactly.
Am I right? Is this the Fedimint and like Minimint, those sort of projects, or is this something that's like distinctly different to those?
This is distinctly different because those are Chalmian mints and they take custody.
That's right.
Of the coin. So,
I guess the way that they not circumvent, but the way that they mitigate that risk is with like many members as a part of the federation, which means it would require some inordinate amount of collaboration for someone to say, take hold of your coins and not give them back. Whereas the solution that you're kind of working through would be even a greater mitigation, where that's not even possible, because like you say, the receiving transaction is sent first, like the outgoing transaction is sent from the hub first before the sender sends it into the hub. I'll probably explain that in a confusing way, but like conceptually I have it right in my head.
Yeah, that's right, how it is. Yeah, I mean, I think if we couldn't do payment hubs, I still think that Chalmian mints are underused. That would be my preferred way of getting privacy, is like it's controversial view, but let's say we just scrapped all the privacy stuff of Lightning and just made payments work all the time, right? Just like don't do the onion routing, just do packet switching, which would probably make it much easier. Like it worked like the internet. You just send a packet out, a payment out, and it just like you figure out how to get it there. Right. And then you can share the destination with everyone along the hop and they can all just do it. Right. So, but then if you wanted privacy, you want to do it privately,
you just go to a Xiaomi Mint and you make, a payment to them, and then you withdraw the payment to whoever you want, and all they see is the Xiaomi Mint is sending, or they don't even see the Xiaomi Mint is sending something, but they see the destination, right? They can see this destination, but no one can know, like even the person who has the Xiaomi is connected to the Xiaomi Mint, no one can know that who it is apart from the Xiaomi, because the Xiaomi Mint doesn't even know who it is.
That's right.
So that's that I think is a okay. Some people will not like that because you're inserting a trusted third party for into the thing, but it's sort of like we discussed privacy in Lightning, and it's quite a confusing story. I mean, you can get good privacy, I think, right? I think you can get really good privacy with Lightning, even as it is today, if you're very careful about certain things and you sort of have it in your head, a full model that we tried to articulate together. But even me, as I'm talking about it, do not properly articulate the full model that exists in my head, which is probably not exactly matched to reality because of implementation details, right?
True, yeah.
So it's like, what privacy guarantee are you actually getting with the current privacy techniques on Lightning? Because we know we get some payment unreliability. Okay, one thing to do is we can just make payments more reliable, but there is a fundamental trade-off there between keeping balances private on this network and making payments reliable. Just like there is a fundamental trade-off. Okay, so what if we just got rid of that and just said, hey, let's use Xiaomi and Mint to make payments if you need them to be private. Otherwise, they'll be the sender will still get the privacy, just like you have the destination there the whole time, right? In each forwarded thing. So it's not that bad. And, the thing is, what you're getting. Okay, you can tell users what you're getting, right? And you can tell it works like the internet, same way your IP traffic works. And you could have VPNs, right? That you sort of hop to them first, which is sort of the idea of trampoline routing, which is one of the ideas, right? So you hop to them first if you don't want to see people to see your destination. You think that they're a relatively good party to hop through for just like a VPN. So like async is already doing that, right? So this is another way to get privacy, even in the packet switch model. So potentially we could make payments super reliable. The same reason we're talking on the internet right now, and the packets are reaching each other because it's packet switched, which makes it easier. And there's capacity constraints and stuff like on the internet and they're probably worse on Bitcoin. They're harder to resolve, right? But you can, every 10 minutes you can get a new transaction in there, which opens up a new channel. So dynamically create these channels, and these routing nodes can, do a good job of having capacity to other parties and not have to rely, take the orders of the sender and not have to tell the sender about the whole topology of the network, right? You just know who you can get to. Right. So this could make payments really reliable. You do degrade privacy there, but maybe people who want privacy should use a specific tool for privacy, like a Xiaomi and Mint. But then what I'm saying with payment hubs, we don't even have to make that trade-off, right? With the payment hub, you don't have to have the custodial trusted third party in there. You can just make private payments through the payment hub. So maybe one thing is that could come with payment hubs is that it just enhances the Lightning network insofar as you could have basically do packet switching, which I think is going to be possible anyway with the protocol changes that are coming. I think you could sort of hack in packet switching onto them. I'm not 100% sure about how it all fits together, but you can see how you could just like get privacy through this intermediary, special intermediaries, Xiaomi banks or payment hubs, or like sort of, trampoline hops like async that you tell them what you're doing, but you sort of trust them. And then you get privacy that way, and then it's no longer related to reliability. There's no longer tension between those two things. So that's what I think is the way forward.
That makes a lot of sense. And it's a very different kind of conceptual shift compared to, I guess, a lot of the solutions that I've heard that are in the works or, at a point of approval and now just implementation. I'm just curious in terms of maybe some of the detail of it. Would the intention be to be the larger hub is better, or would it be better for them to be distributed? But then, of course, that would maybe impact the kind of capacity. By hubs, I mean like the idea that you think.
I think it happens like I said, it's like sort of already what happens naturally in Lightning, but probably accelerates it a bit or like increases that because you no longer have this privacy problem with it. So it's like the more payment, it increases this tendency towards making channels with people who already have a lot of channels, right? There's payment hubs, right? And these payment hubs, instead of just being naturally people who have a lot of channels, would stick their hands up. I mean, I'm a payment hub and I route. I mean, we make payments in this very particular way with this very particular protocol with me. And they would be, yeah. So that would centralize the network. The topology would become more hub and spoke than before. Now, would it make sense to go like all the way, right? Just have a single payment hub, and would they just defeat all the competition? I think that is unlikely, just because it's sort of if you have only a single payment hub, that payment hub can, although it's private, it can go down, and then everyone has their coins locked for some time, similar to how payment, if your Lightning intermediary goes down, your payments, your channel's locked for some time before you can recover the coins. And so it would be the same kind of problem. So I imagine that there would be a few, but a small number of them. If it would be taken to an extreme, and maybe it doesn't, maybe it remains a niche thing like a coin join, right? You have these coin join coordinators that are there, and like you make these payment hubs, which are like bespoke people that don't really get a lot of traction or on the periphery of the network, and you use them. Really educated people, privacy aware people just use them, and everyone else uses the normal Lightning network. And that could be advantageous, like I said, because then privacy conscious people have an option that they can use to get payments through the Lightning network. That is really really good. And then everyone else is just using packet switching.
That's right. Yeah, which less private but more reliable. Yeah.
So there could be it could be a very decentralized Lightning network there, just using, or not very decentralized, but more or less how it is now, but using packet switching more reliably. And then you have bespoke nodes that do the payment hub protocol for people who care about privacy. But it could also go the other way, and that you have a payment hub that doesn't even connect to the Lightning network, right? It just competes with the Lightning network, and then you make a payment, and it just goes through to people. It can only go to people who connect to that payment hub. You can imagine a proprietary company starting that thing, and maybe trying to compete with the Lightning network, having instant off-chain payments that are really, really very private, and maybe even offering on-ramps on Lightning itself, and then just sort of taking over the market that way and becoming a very centralized thing. I don't know how things will turn out, and maybe it'll just be a nothing burger, completely. But where there is a downside to the payment hubs, so the payment hubs, like similar to Xiaomi and Mints, there's no proof of payment. Okay, so when you make those Lightning payments, you get this kind of proof that you paid, and it's sort of easy to agree that you did definitely pay. Whereas with this Xiaomi and this Xiaomi and Mints and the payment hubs, you just know that you lost money, and it should be impossible that you lost money to anyone else other than the guy you intended to, right? So you don't have a proof that you got it, and you cannot prove to anyone else that you definitely they definitely got the money. It's like cash. It's like as soon as you give the $50 to them, you can say, what $50, right?
Otherwise it defeats the purpose. Yeah, that's true.
Yeah, so the privacy has this implication, this side effect that makes it very much like cash. And so maybe maybe Lightning services find this inconvenient or whatever. I don't know. It's all for us to find out.
Very true. And so is this is sort of at a theoretical stage, or have you seen people working on parts of the implementation? Or
it's totally theory right now. We're working on. I mean, the payment hub. There's payment hubs that already exist. Okay, first, the theoretical papers that just have had proof of concept implementations, and so there's that. But I can tell you that I don't think anyone is working on bringing those existing payment hubs into production. But I'm working with some people to bring a new publication on a very efficient payment hub, more efficient than the other payment hubs, and doesn't require any new cryptographic primitives. Just works with the existing SecP 256K1 elliptic curve that we already use for all of Bitcoin's existing cryptography. And so that would be fantastic if we could achieve that. We haven't written the full proof of security and stuff like that yet. It's sort of just an idea that comes from an existing paper we just published. So it's sort of like repurposing that idea for payment hubs. And I think it's going to work, though. I'm pretty confident that this works.
It sounds very cool conceptually because I was aware of the Fedimint and kind of Xiaomi and eCash project. And I know that's been gaining a bit of traction, especially with like the likes of Alex Gladstein kind of pushing for it. And I think Human Rights Foundation has donated some grants and so forth for it. And that sounded good, but at the same time, yeah, with the custodial trade-off, which is normally the thing that kind of it becomes a sticking point, at least for me in regards to privacy. So I like the fact that this is similar in terms of its function, but just it takes away that custodial risk.
So let's there is, I think those two concepts integrate together though. So this payment hub, it will not be able to sort of do small amounts very well. Okay, so payment hub, it still has like this problem that you have with CoinJoin is that you have like these single amounts, right? The uniform amounts in CoinJoins, right? But the difference is that you can have as many multiples of that amount in a single output as you want, and still it can be a payment. Okay, so it's like I think a million sats is a reasonable practical amount, right? So it's like you want to buy 1 Bitcoin, which is 100 million sats, or you want to send 1 Bitcoin, you'll need to sort of run this protocol 100 times in parallel. Okay, so it's like in order to purchase a 1 Bitcoin output from the payment hub, you'll need to, in a single session or multiple different anonymized sessions, purchase like 100 unlockings, right? 100 this protocol 100 sessions as the sender of the payment. And so you have to choose an amount that each key is worth, actually. So it ends up being each amount is represented as key in the output. Okay, you need to purchase all the keys in order to get to unlock the coins. And so you need to choose an amount, and this means you need a way of doing change, right? Or less, but smaller denominations. I think that a Xiaomi eCash is the right way, right? If it's less than 1 million sats, you send the rest as eCash. Okay, but it's for larger payments, so you want to keep the bulk of it custodial, non-custodial. You use the payment hub protocol, but then if there's extra on the end, you use the eCash, and so your eCash can build up. And I think you can make it so sending stuff using eCash, the eCash can add to the anon set of the payment hub. I think that's sort of like an experimental idea, but you could imagine that if I'm like purchasing openings, it's impossible for me, the payment hub, to distinguish between purchasing openings and purchasing eCash, right? So it's like the eCash system of the Xiaomi Mint and the payment hub system are complementary to each other and sort of form the same anon set. So if your eCash is popular, and there are reasons to use eCash that are practical, even though they involve custody. For example, I get annoyed by exchanges telling me that I'm using privacy tools when I deposit them, when I use a CoinJoin. So what if I use a Xiaomi and Mint, right? I'm trying to send coins to an exchange to do some degenerate gambling, or maybe sell some, God forbid. But then I send it through the Xiaomi and Mint, right? And so I'm not leaving coins with the Xiaomi and Mint. I've got some kind of channel with the Xiaomi and Mint, or I just send an on-chain transactions to the Xiaomi and Mint. Then I get the minted coins, and then I tell it to send to the exchange. Now, it is custodial, but also the exchange is custodial, right? So it's not. This makes total sense to me, and the exchange cannot tell this transaction differentiate from any other transaction, and cannot send me an email about that I'm using this Xiaomi and Mint. With the payment hub,
what happened before the Xiaomi and Mint?
Say again?
Or they wouldn't be able to see what happened before the Xiaomi and Mint as well.
That's right. They just get some coins with some random history that someone also previously deposited into the Xiaomi and Mint, right? So this is fantastic. So every coin that an exchange sees now has nothing to do with the coins the user has, which is exactly what we want, right? Now they do have a history, but it's like a randomly sampled history. You could get, I don't know, Osama bin Laden's coins and be sending them, and then I don't know, they get angry about it. But I mean, it's not your fault, right? And it's just that people move to exchanges that don't freeze accounts based on this, right? And most of the coins won't be Osama bin Laden coins. They'll be like, I don't know, hodler coins, right? It may make sense as when you withdraw from the exchange, before you put them in cold storage, you put them into the Xiaomi Mint and withdraw them, right? You just had your coins on a custodial entity, so you surely will be able to handle being in another custodial entity for a small amount of time as you withdraw them, right?
That's right.
So I think this makes a lot of sense, and you cannot do that scenario with a payment hub where you pay to an exchange, unless the exchange is willing to do the payment hub receiving protocol, right? Because it's a different protocol. You have to know the coins you're receiving are payment hub coins and know what you're doing. So with the Chaumian Mint, because you have the custody in there, it solves two problems: the small amount problem, and like when you just want to pay to an address straight up, without you could, well, obviously with the payment hub, you could first receive the payment hub coins to yourself, non-custodially, and then send them on to the custodian. But if you're already sending to a custodian, I think it makes sense just to do it all in one go, right? Just have to find a payment hub that, a Chaumian Mint / payment hub that you think is good, right? Is not going to steal your coins, and you don't leave them there. That's the key. There's no point in leaving coins on a Chaumian Mint for a long time, like as a cold storage solution, right? The advantage of all these services where you leave custodial services is that you have a way of getting the coins if you forget your seed words or whatever, right? You have your email or whatever, and you can go to them and do some social recovery and get the coins back. That's the advantage. With Chaumian Mint, you don't have that. There's really no point to leave coins in a Chaumian Mint, but they are very handy as intermediary custodians that temporarily take custody of coins and facilitate a payment that is unlinkable in all circumstances. And that we have the payment hub protocol now, if it works, to do it for large amounts non-custodially, right? So yeah, I think it's very nice.
Absolutely, yeah. It addresses a lot of the issues, and yeah, I'm just thinking like what can users expect in regards to some of these ideas? Is this like, are we talking years and years down the track? Is this something that, given that you're using the ECDSA signature scheme for it already, does that make it something that's easier to implement once it's past that kind of theory and looking in the security side of things?
We'll be using, I think it's using Schnorr. I will use Schnorr.
Oh, gotcha.
Yeah, probably. But it could actually, the idea I have in mind actually could use ECDSA, and then probably some people like that because they don't want to be part of the Schnorr and onset, right? Because maybe Schnorr signatures means you're being naughty in the future,
Yeah.
We have actually like if you don't want things to be too fast. So your listeners, should take care. If we manage to get this all working today, then probably exchanges can be like, no, like you'll probably get an email if you withdraw to a Schnorr address, right? A taproot address.
So what are you trying to hide? Yeah.
Yeah, exactly. So we need the exchanges to like slowly adopt SegWit v1, which is the Schnorr taproot addresses. And then once they've done that, then they won't be able to get rid of it, and we'll be able to have all these fun privacy tools. So we don't want to go too fast. Now, on the timeline thing, the work that I can see on Chaumian Mints, and I'm excited about Chaumian. I want to get involved in that space a bit as I work on payment hubs. So I'm glad to see it's getting funded. Right now, the problem they have is the same as the problem as the coin join, the uniform amount coin joins, is that Chaumian Mints have a certain coin which has a certain value, and you deposit and withdraw those coins individually. Although those coins cannot be linked to the incoming coins cannot be linked to the outgoing coins, they're all the same amount. We know how to do that better. I think we've got on Bitcoin problems. I haven't got a problem page, but I've got in a GitHub issue on the Git Bitcoin problems repository about this. And I think the theory looks like in the issue comments, we have the theory we need to make it variable amounts, so whatever amount you want. You could deposit, 1 Bitcoin, withdraw 0.2 Bitcoins or whatever, however much you want from the Chaumian Mint. And that 10x is the usefulness of it. 100x is it. It's absolutely necessary for a Chaumian Mint to be practical to do that, I think. And so to have it be able to deposit and withdraw whatever amounts you want, and the exchange doesn't learn anything other than that. We need that. And so that's not yet implemented, but I'm trying to sort of poke people and figure out if we can put together a team to implement that as a sort of like as maybe the Fedi Mint project. I haven't talked to them about it, but they're part of the discussion on the GitHub issue, but maybe contribute that to them so that we have a Chaumian Mint project that has like variable amounts. That would be like a first big step. And I don't know how long that's going to take, but I don't know. Hopefully in the 12 months, I would say would hopefully have a Chaumian Mint that can do that somewhere. And then payment hubs, obviously, we're just in the theory stage of this new protocol. But maybe proof of concept or somewhere like around in 12 months time as well, running up there where people can use it. And then, we said without the UX, like the question is, when is that I have a freaking good UX that I can just like put my coins in and everything I do is freaking private. And it's just simple as hell. I think the good thing is, I don't know when that's going to happen, honestly, but the thing that is crucial is that we now have a theoretical path, if this payment hub thing, works out, to get there. Okay. But we can have non-custodial, very private Bitcoin, I believe. So we have a pathway there.
And look, to be honest, to see even like the Fedimint project coming to like the kind of Xiaomi and eCash coming to fruition in the next sort of 12-ish months, where someone can then kind of experiment with it, I think that's awesome. And then the fact, if we're 12 or 24 months after that, starting to look at this, like the more kind of payment hub scheme that you're discussing, I think that's great. I think that's still relatively soon in the grand scheme of things. And I'm just trying to sort of bring this back to something practical for people to take away. I'm kind of loath to put out a bunch of rules or suggestions that people should follow, because I'm much more of the conceptually understand it and then try to apply it to your unique circumstances, and then experiment and kind of keep coming back to the conceptual model and keep coming back to what you're trying to accomplish, which sometimes I'll call like the threat model. What are you actually trying to, or who are you trying to remain private from? So I don't really want to put out any strict rules or guidance of what people should do if they're a sender versus receiver. Like, there is already content out there that's like that, which maybe I'll just perhaps link in the show notes. I think it's probably better for people to take away the discussion and some of the conceptual framework that we laid out earlier on in terms of Lightning Network pros and cons, as well as also to know the fact that there's at least a couple of things being worked on which are going to, push the improvements further in that hub and spoke model. Having said that, I don't want to kind of like circumvent any suggestions or any recommendations which you were going to throw in when we got to that section. So I guess I'll probably bow out and say I'm not gonna put too many suggestions there. I do like some of Anthony Ronning's article around, it came out in like 2021, which was like the state of Lightning Network privacy. What should senders do? What should receivers do? What general concepts to keep in mind? A lot of which we've touched on in this conversation. So I'd say if users do want some, here are the take-home points, perhaps look at that while listening back to this podcast. But was there anything that you thought?
I would definitely recommend that you go to those kind of people you suggested. I mean, of course, if you find like this, you've learned some theory or some way of thinking, and you find that some points that they've made are wrong or perhaps too emphasized or some missing, then that's great. You can add to what they've said, but I would take them as the primary advice. I also want to say, if you're doing something like illegal or illicit, you're a human rights activist and you could be caught by doing something wrong here, make sure not to use this as your sole source of information. 100%. The conversation I guess we're having is mostly for people who are just trying to do best practices and avoid leaking more information than they would otherwise would, right? If they didn't know this stuff. I think that's where we're targeting. If you're doing something that you really need to make sure is private, you have to study the shit out of things at the present. You have to really focus on understanding it and setting up yourself correctly. And I don't want to put anything forward for you that isn't other than theory and ways of thinking about the things. So that's what I'd say.
That makes sense, and I think that's a pretty good approach to take. And I do agree. I think the majority of people are just trying to reduce their footprint or their fingerprint in like a dragnet surveillance system, in which case I think there are plenty of tools available to reduce that enough to be significant. But you're right. If you're a political activist or a dissident or doing anything that's completely illicit, you probably want to know this a little bit better. And maybe I would even hazard a guess that Lightning Network might not be for you at the moment. It might be more so using on-chain tools. But even then, you need to know it relatively well to make sure that you're not making any kind of obvious faux pas. But watch this space, because it sounds like there's a whole lot coming, which is really cool.
Yeah, cool.
Did you have any final thoughts before we finish up? I was going to say, don't worry so much about your socials. I can link them in the show notes and everything else. But any kind of final take-home points or anything that we didn't talk about that you thought we were going to talk about that would be good to finish up on?
No, I think you've actually exhausted my useful things I have to say about technical Bitcoin things. So well done.
That's great. I love to hear it.
want to say that we probably have some Australians listening. We're mostly Australian audience, I guess. I hope I run the Bitcoin Sydney Socratic. So if you're interested in these kind of topics, we usually get one person to come on each month or so to talk about things going on. And you can join and ask questions, so different to a podcast format, but similar, right? So you sort of interviewing someone, but like interviewed by a crowd, if you like. It's sort of what we do, and pick their brains. So we do that once a month. You'll see it on if you link my Twitter, but maybe you can link the Bitcoin Sydney Socratic. But we are about to move to maybe a new format because I'm here in Malaysia, and I have some people who are going to volunteer sort of helping me with this project. We're maybe changing to more like an Asia Pacific Socratic. I'd be keen to have people join. If they're certainly the people who are interested in this discussion should be joining if they're in the Asia Pacific region. That's what I'd like to say.
That sounds great. Yeah, please do, because I'll put it up, and you'll probably see me there at one of the meetings, because I wasn't aware of that, or maybe I was, but it's like this vague recollection in the back of my mind. But that certainly sounds like something I'd be keen to go to, and especially if it's no longer kind of physical location, you can kind of join by video link or something. Sounds perfect. That's really cool. Well,
great. Thanks, Justin.
No worries, Lloyd. Thank you very much for your time. It's been enlightening for me, and there's a lot of cool stuff to look forward to. And thank you for sharing something that sounds like it's conceptual shift in terms of how to look at Lightning Network privacy. And obviously, that's something that you're working on and have put a lot of thought into. So I appreciate you sharing it before it's sort of like, ready to be released, so to speak.
Yeah, thanks very much. I really appreciate this conversation. I found it useful, and everything I say is obviously just my opinion here, and no one working on Lightning necessarily even knows about these things or even agrees with what I think. There's just a disclaimer there at the end. I'm certainly could find people that disagree with me on this stuff, but we'll see.
And look, with anything that's new and kind of rapidly facing discoveries, there's plenty of unknowns in all of this as well. So I think, kind of everything in this space to some degrees, take with a grain of salt. It could actually change. But I mean, that's the beauty of just continually learning and trying to get your head around it.
That's it.
Thanks again for your time. And thanks everyone for listening. And until next time.